So last but not least, it's a great pleasure for us to have the Honorable Mike Honda here. Mike represents the 17th District of California. That's the San Jose Silicon Valley District in the U.S. House of Representatives. I think it's fair to say there is no greater advocate for federal funding of nanotechnology on the Hill than Mike. And he is, importantly, among other things, the co-author of the bill that Paul mentioned, the 21st Century Nanotechnology Research and Development Act. And this authorized funding in sort of the early 2000s all over the federal government for nanoscience and nanotechnology research. And Representative Mike Honda is a long-term supporter of the Foundry. There's a picture of our groundbreaking on the wall somewhere, and yeah, there he is up there. And so, and he's kind of been there from the very beginning, and a huge supporter of us. And without him, we wouldn't be here. So it's a real pleasure, Representative Mike Honda.
This is really exciting to be here. I had a sense when I walked into this room that the average intelligence quotient just dropped when I walked in. It's really kind of nicely intimidating to be with all of you. And I just want to thank you very much for letting me be part of this celebration, this incredible decade. And let me first congratulate the new director of Berkeley Labs, Mike Witherell, and say thanks to the director of Molecular Foundry, Jeff Neaton, for his great work. He told me he went from postdoc to leader, so if you stick around long enough, you could get a good job here. He told me. And I especially want to thank Paul Alvisatos, who I met when I first got involved with nanotechnology. Paul, you did a great job in leading the Molecular Foundry from its inception and during your time as director of Berkeley Labs. And watching you up here, I could tell that there's a part of you that really can get excited and, love your smile and in the way you just reflect the kind of excitement that you have. And you think that scientists like him, is kind of, even and everything, but I saw this almost childlike excitement and expectation. So thank you for all that. You've been a great valued resource to me, and you've done a great job in explaining what you and the folks at the lab are working on. Your leadership of the lab will be missed, but congratulations also to your new role as Vice Chancellor of Research down the hill at UC Berkeley. And I'd be very remiss if I didn't also thank Don Medley, as a good friend and who's worked with us behind the scenes for all these many years and did a lot of interpreting and also interacting with my staff. And I just have to say that, give a lot of credit to me, but you know that politicians always have good, smart staff. And my partner in the staff was a fellow by the name of Dr. Eric Werwa, who is a PhD in material science from MIT. And when I heard the word nanotechnology, we started talking. And so it's really hard to believe that the Foundry has been open for 10 years. And I was here, as it was said, for the groundbreaking ceremony. It was a day that it was rainy for a while, and I think Pat, in anticipation of more rain, built a sandbox inside the building. And that was the ground that we turned over. If we left it alone, I think that all the cats in this neighborhood would have been here by then. But it was a lot of fun. And that came really on the heels of the enactment of the 21st Century Nanotechnology Research and Development Act, which President George W. Bush signed into law on December 3rd, 2003. Most members of Congress probably didn't know anything about nanotechnology before the House considered that bill. President Clinton had created a National Nanotechnology Initiative, the NNI, in his fiscal year 2001 budget, and President Bush continued to fund it. I first learned about nanotechnology and the NNI during a visit to NASA's Ames Research Center in Silicon Valley, where researchers in 1996 began working in the field of nano. And when I visited labs and attended conferences to learn more about nanotechnology, I spoke with the scientists and engineers about their vision, their needs, and their concerns, and I started thinking about writing legislation based on what I heard from them and on the recommendations of the National Research Council's 2002 review of the NNI. I grabbed a few of those ideas and drafted a bill to implement them, as setting down a marker so when Congress was ready to do a larger bill, that I'd be in that mix. And I joined with then Science Committee Chairman Sherry Bullard, Republican, on the task of putting the nanotechnology research and development program into law. And we wrote and introduced H.R. 766, the Nanotechnology Research and Development Act. And the House overwhelmingly approved H.R. 766 by a vote of 405 to 19. I haven't seen that since. And then there were negotiations, as usual, between the House and Senate to work out the differences between the two versions of the bill, and the Senate, in their wisdom, added another year to the bill and another $1 billion and their name. But that's okay. I mean, another $1 billion is cash that we wanted to see. So the end product was an amended version of Science Bill 189, the 21st Century Nanotechnology Research and Development Act. And that bill enshrined the NNI into law, authorizing nearly $4 billion in spending over 4 years on nanotechnology research, development, demonstration, education, technology transfer, and commercial application activities. And among other things, it charged the Department of Energy with establishing advanced technology user facilities, which gave rise to the Molecular Foundry and other DOE nanotech facilities across this country. And I suspect that this is probably the best one across the country, right? And listening to the comments, I think that one of the things that really do make you unique was that term, democratization. And democratization, sharing, collaborating is really who we are and who you are. It really moves this whole country forward. So the Molecular Foundry has enabled exciting discoveries and development of new technologies by giving researchers and industry users access to equipment and expertise they couldn't otherwise afford to have, as has been said earlier. And that was really cool too, Magic Leap. It's on Netflix, or do I just have to go online? I want to take my grandkids there. The Foundry is also leveraging other federal R&D programs, and that's important, enabling us to get even more bang for the taxpayers' bucks. For example, last year, 2 projects in the lab's Sucatron Road Early Stage Energy Technology Incubation Program, both of which are users at the Molecular Foundry, received funding through the Advanced Research Projects Agency for Energy, ARPA-E. A team working on thermionics energy converter. I'm a science teacher, I'll learn how to say that. And this thing can convert heat to electricity, and it received a little over $3.6 million from ARPA-E. And the team working on an infrared reflective coating to retrofit inefficient windows in buildings was awarded $3.9 million. We could use some of that stuff in Congress, too. Last year, the Foundry industrial user Xtherma was named a winner of the Patrick Soon-Shiong Innovation Award for its radical new non-toxic, hyper-effective antifreeze agent to fight unwanted ice formation in regenerative medicine. You get that? It's important. Advanced formulation cosmetics, enhanced quality frozen food, which I think is important too, and industrial de-icing applications. The Foundry scientist and industrial user A-Beam Technologies won a 2015 100 award for developing new technology that can be used for calibrating a broad range of optical instruments, including those used for extreme ultraviolet lithography, which is important to semiconductor industry and high-precision visible light optics. In another project, Foundry researchers and with users from Livermore Lab have developed artificial pores made of short carbon nanotubes that can self-insert into cell membrane, making them candidates for drug delivery systems and biosensors. If you just can picture that at the cellular level, you're having these carbon nanotubes doing that. And I think that this is going to be earth-shaking and groundbreaking for folks like myself who's getting older and want to figure out how you keep these cells from getting too old. Now, Intel, which is based in my district, has partnered with the Foundry to reduce the size of lines and features on the surfaces of microchips and to enhance the cooling of microprocessor chips sixfold through carbon nanotubes bonded to the surface. And in 2013, Foundry scientists won an R&D 100 award for developing a universal smart window coating that enables dynamic control over how much the sun's heat and light enters into a building through its windows. And I should also mention the outstanding work that has been done by Paul here, who is being awarded the National Medal of Science this year for his work developing quantum dots that are now being used in commercial products like energy-efficient solid-state lighting and high-resolution video displays like Kindle Fire, and for my grandkids, the TV set. These quantum dots are also used in biological and medical imaging tools made by Thermo Fisher Scientific. Nanosys, a company that Paul started, which is now located in Milpitas, my congressional district, it's great, is producing 25 tons of nanoparticles each year and employs about 100 people. If you can imagine what 25 tons of nanoparticles look like, you know, how many particles that must be. It's mind-boggling. So looking beyond the Foundry, the National Technology Coordination Office's Industrial Liaison recently conducted an informal survey of nanotech-related businesses. And they found over 100 companies involved in nanotech R&D, nanomanufacturing, and the marketing of nanotech-based products in my congressional district alone. So many of these companies have received federal support through Small Business Innovation Research and Small Business Technology Transfer programs of various federal agencies. MagArray in Milpitas is commercializing a magneto-nanosensor currently conducting clinical trials to evaluate for detecting lung and prostate cancer biomarkers. Prostate cancer, listen up you guys. Vorbeck Materials in Maryland received NNI funding for the development of conductive inks for use in wearable electronics, communications, and security coding. It has filed over 80 patents and has seen its workforce grow by 200%. Its links are being used by Fortune 10 companies and well-known household brands. Another group, AuraSense, used NNI funding to develop smart flare gold nanoparticle probes for the early stage detection of a variety of life-threatening diseases such as breast and prostate cancer. Currently, about 1,600 smart flare-based products are being sold by EMD Millipore in over 230 countries. So it's creating jobs and it's spreading around the world. And NNI supported Liquidia to successfully apply nanofabrication approaches to the development of a roll-to-roll based method for the production of novel drug and vaccine delivery platforms. Now, this technology has been licensed to GlaxoSmithKline for the development of inhalation-based therapeutics, has led to a spin-off company, Envisia Technologies, which currently has an ophthalmology product in phase 2A clinics trials. Now, there are many great examples of scientific discoveries enabled by the NNI that have been taken from the lab and turned into a variety of products that are on the market, creating revenue and employing people around the region and in this country. Now, what do we need to do to look into the future and what remains to be done? Even as we celebrate these discoveries and inventions, the United States is still making healthy investments in nanotechnology-related activities. The President's budget request for this past 2016 called for a total investment of $1.5 billion. That brought the United States government's investment in nanotechnology to more than $22 billion cumulatively since the inception of the NNI in 2001. Now, as someone who has been a supporter of nanotechnology research throughout my tenure in Congress, I'm glad to see this progress and continued commitment by the federal agencies. Nearly half of the proposed 2016 funding was focused on applied R&D and support for signature initiatives on issues of national importance. The increased emphasis on commercialization and technology transfer is welcome, and I think it dovetails nicely with some exciting things the Department of Energy is doing to promote commercialization, like this cyclotron road program here at Berkeley Lab. With the global nanotechnology now projected to grow to reach about $75.8 billion by the year 2020, there are plenty of reasons for the United States to want to make sure it keeps its fair share. But our country has a lackluster record of providing support for bringing technologies that we have developed to market. Federal support for the commercialization of technology has been a thorny political issue, raising criticism that it is corporate welfare and that we should let the market decide. Yet, when the House Science Committee held hearings on nanotechnology, we heard from a professional investor testifying and saying that we needed to focus on commercialization of nanotechnology and that we must find a way to use nanotechnology to give taxpayers a return on their investment, develop the economy, and create good, high-paying jobs. He explained that despite the effort of their founders and the quality of their technology, many startup companies will not be funded by private equity sources because they cannot afford to bridge the gap from the laboratory to the marketplace. Funding that jump is too risky for venture firms that must deliver competitive returns in a limited time frame. So when I convened the California Blue Ribbon Task Force on Nanotechnology, and I want to thank Paul and Don for being great in helping me do that, we heard even more about this challenge. Building upon the policy recommendations that the task force made in the report, Thinking Big About Thinking Small, I developed a bill that Nanotechnology Advancement and New Opportunities Act, we call it the Nano Act. Through the Nano Act, I've been trying to bring a focus on the commercialization of nanotechnology, which is why Nano Business Commercialization Association had endorsed it. The bill will set up a public-private partnership to provide funding for pre-commercial nanomanufacturing R&D projects. It would also establish a nanotechnology startup advisory council and develop incubators with academic institutions to promote emerging technologies and startups. And would promote work to employ nanotechnology to address areas of national need like renewable energy, much like what the National Nanotechnology Initiative has been doing with its nanoscale signature initiatives. By instituting programs like these to help move discoveries out of the lab and support startups, we can maximize the value and utility of the molecular foundry and other user facilities. More users mean more discovery, more learning, more collaborations, and more jobs. Unfortunately, Congress hadn't had much of an appetite for bold action on nanotechnology over the last few years, so we continue to fund ongoing programs from my perspective as the lead Democrat on the Commerce, Justice, and Science Appropriations Subcommittee and a member of the Energy and Water Development Appropriations Subcommittee. There is a fairly solid support for the nanoscience and nanotechnology programs among appropriators. But when it comes to authorizers, in authorizing new activities, it has been a struggle. A couple of years ago, I thought we had a chance, and I worked with the ranking member of the Science, Space, and Technology Committee to try to get some of the core elements of my Nano Act into reauthorizing and the reauthorization of American Competes Act. While a Competes reauthorization didn't happen then, it seems unlikely to happen during the limited amount of time we have available for the rest of this year. The U.S. remaining a leader in nanotechnology is still an essential part of the goal of Competes, to improve the competitiveness of the United States. That's why we need to keep working in a variety of ways to ensure that the U.S. government supports and encourages nanotechnology, R&D, as well as the commercialization of research by industry. We need to support focused research that can benefit from the use of nanotechnology, such as President Obama's brain research through advancing innovative newer technologies, that initiative, which is looking at nanoparticles invented by Paul here for brain imaging applications. We need to embrace the notion that the federal government should partner with the private sector to provide companies with the funding they need to bridge that gap to market. And we must continue to provide support through the NNI for user facilities like the molecular Foundry, which provide unmatched access to equipment and expertise that can make a difference for a company trying to succeed. And I really do look forward to working with all of you to keep the Foundry flourishing for its second decade through the right mix of policies and funding priorities that will keep us ahead of our international competitors in a race to the future. And I just have to say, I think sometimes I was born too early, and folks like yourself get to do all these great things at the nanoscale level. But let me just say that as a public servant and as a elected official with a science teaching background, it's been humbling to be able to do this kind of work. And always know that utilizing folks like myself in our offices and getting folks like yourselves into offices that work on policy in Congress is critical, so that folks in these offices will be taught by people like yourselves to policymakers to come up with better and more future-looking endeavors in order for us to be able to realize the kinds of dreams and imaginations that we can see, such as Magic Leap, and also correcting and addressing the kinds of issues that we need to address in terms of our own health, our longevity, the quality of our life, the quality of our environment, and becoming a more democratic in the use and the availability of energy so that everybody can be able to benefit from all of that. So to all of you, again, I say humbly thank you for this wonderful opportunity.